Hi there. For this topic, we'll be looking at the different features of tropical storms. So they have several main features. Firstly, they last between 7 and 14 days. So between 1 and 2 weeks usually. They tend to have a circular shape and are hundreds of kilometres wide. The direction they spin depends on the hemisphere. So in the northern hemisphere, tropical storms spin anti-clockwise, and in the southern hemisphere, they spin clockwise. So it'll be different depending on the hemisphere they're in. They also have an eye wall and edges. In the eye, there is descending air, low air pressure, no clouds, rain or wind, and a high temperature. In the eye wall, which is the bit between the eye and the edges, there's rising air, strong winds, storm clouds, torrential rain, and low temperature. And then towards the edges, there's smaller scattered clouds, less rain, rise in temperature, and falling wind speed. Let's do a quick recap of that then. So the different features of tropical storms are: the spin direction depends on the hemisphere. They can be hundreds of kilometres wide. They last 7 to 14 days and have a circular shape. Now let's have a look at the structure. I already touched upon this. So the storm centre is known as the eye, and it can be up to 50 kilometres wide. This eye is caused by sinking air. It's sort of like the hole you see in the middle of a tropical storm if you look at it from above. The conditions in the eye are low pressure, high temperature, and minimal rain, wind, and cloud. Then the eye wall surrounds the eye of the storm. And the conditions in the eye wall are spiralling, rising air, low temperature, and lots of wind, clouds, and rain. And then finally, the edge of the storms, they have intermediate conditions with intermediate wind speeds, intermediate rain intensity, and temperatures that are all moderate. And the clouds are small and scattered. So there's a real difference between all the different kind of conditions. So let's just do a quick recap. What are the conditions in the eye? There's no rain, no clouds, low pressure, light winds, and a high temperature. Then the conditions in the eye wall are spiraling rising air, low temperature, and lots of wind, clouds, and rain. Now let's look at a new topic, the effects of climate change on storms. Climate change is likely to affect the distribution, frequency, and intensity of tropical storms for several reasons. Firstly, distribution. So climate change is expected to lead to increases in temperatures, which means that lots of the oceans across the world are going to get warmer. And obviously, warm temperatures are what cause tropical storms in the first place. So more places in the world will be warmer than 27 degrees C, and therefore tropical storms will happen in more places. So more places around the world will have the kind of ocean conditions that are required for tropical storms to take place. Secondly, the frequency. So these oceans will now be at that, in the future will be at these high temperatures for a longer time of the year, which means that the frequency of storms will rise. So in oceans where they don't reach 27 degrees all year round, they might start reaching that temperature more often in the year, which means more risk of tropical storms. Finally, the intensity. The higher the temperatures, the greater the intensity of the storm, because higher temperatures cause higher energy in storms. So more intense storms will then cause more damage. So these are the effects of climate change on storms. Now let's just do a little quick recap of that. At what temperatures do ocean tropical storms develop? 27 degrees and above. Which aspects of tropical storms will climate change affect? That's the frequency, the intensity, and the distribution. Now, which direction do tropical storms spin in each hemisphere? In the southern hemisphere, tropical storms spin clockwise, and in the northern hemisphere, they spin anti-clockwise. Climate change is likely to affect the distribution, the frequency, and the intensity of tropical storms.